projects. In this video, we are going to explain about a project titled Diabetes Retinopathy Classification Using Machine Learning with CNN Features. Diabetic retinopathy is a leading cause of blindness worldwide, necessitating the early and accurate detection for effective intervention. In this project, we harness the power of convolutional neural network for the feature extraction and integrate the various machine learning algorithms, including KNN, random forest, and of many more. Leveraging an extensive data set of retinal images, our goal is to develop a robust and accurate classification system. By comparing the performance of diverse algorithms, we strive to identify the optimal model for the diabetic retinopathy classification. This project holds the immense promise in revolutionizing the healthcare by enabling the timely diagnosis and the intervention, potentially preventing the blindness and improving the patient outcome. And the objective of this project is to create an advanced diabetes retinopathy classification system using machine learning. By importing the essential libraries and of using of various machine learning models like of KNN, random forest, SVM, logistic regression, Neo-Bayes, XGBoost, AdaBoost, decision tree, and the voting classifier. Through rigorous evaluation, we seek to identify the most accurate and efficient approach for the diabetic retinopathy classification. Our primary goal is to empower the healthcare professional with a reliable tool for early detection and the intervention, potentially saving the countless sight-threatening complications and improving the patient care. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary Python libraries are imported, such as TensorFlow, sklearn, Pandas, and Flask. These libraries provide the essential functions to perform the subsequent tasks efficiently. And second one is importing the dataset. The dataset containing retinal images of patients with the diabetes is loaded into the project. Each image is associated with a corresponding label indicating the severity of the diabetic retinopathy. And the third one is image scaling and processing. Before feeding the images into the CNN model, they undergo the pre-processing steps such as of resizing and normalization. To ensure the consistency and better model convergence, this step enhances the image quality, reduce the computation time, and contribute to the improved classification accuracy. And the next step is model building. In this case, the multiple machine learning models are constructed, and the first one is of CNN feature extraction. CNN are deep learning models specifically designed for image analysis. In this project, CNN is utilized to automatically extract the relevant features from the retinal images. The CNN learn to recognize the pattern and the structure in the images, enabling it to capture the intricate details that aid in accurate diabetic retinopathy classification. CNN ability to learn the hierarchical representation make it a powerful tool for the feature extraction and its combination with the other machine learning models. And the second one is KNN. KNN stands for K nearest neighbor, is a simple and initiative machine learning algorithm used for the classification task. It operates based on the principle of similarity, where a test image is classified by comparing it to the K closest training images in the feature space. In this project, KNN is applied to extract the features from the CNN to classify the diabetic retinopathy severity based on the similarities with the nearest training data point. And the third one is random forest. Random forest is an ensemble learning method that constructs the multiple decision tree using the training process. Each decision tree is built on randomly selected subset of data, and the final classification is determined by aggregating the prediction of all individual trees. By utilizing the random forest in the project, the model aims to exploit the diversity of decision tree to achieve the higher accuracy and robustness in diabetic retinopathy classification. And the next one is SVM. It stands for Support Vector Mission, is a powerful supervised learning algorithm used for the classification task. It finds an optimal hyperplane that best separates the different classes in the feature space. SVM can handle the high-dimensional data efficiently, making it suitable for the extracted features from the CNN. SVM ability to maximize the margin between the classes aids in identifying the decision boundary effectively, contributing to the accurate diabetic retinopathy classification. And the next step is logistic regression. Logistic regression is a simple and effective classification algorithm. It probability of sample the belonging to the particular class using a logistic function. In this project, it be applied as a baseline model directly using the extracted features from the CNN to predict the probability of the different diabetic retinopathy severity classes. And the next one is Bayes. Bayes is a probabilistic classification algorithm based on the Bayes theorem. Despite its simplicity, it performs well in certain scenarios, especially when dealing with the high-dimensional data. By applying the Bayes to the CNN features, the model can efficiently classify the diabetic retinopathy by estimating the conditional probability of the different severity classes. And the next one is XGBoost. It stands for Extreme Gradient Boosting and is an optimized gradient boosting algorithm known for its high performance and the scalability. It builds an ensemble of weak learners in a sequential manner, refining the model's accuracy through the iteration. By integrating the XGBoost into the project, the model aims to improve the classification performance of the diabetic retinopathy by learning from the mistake and focusing on misclassified instance. And the next one is AdaBoost. It stands for Adaptive Boosting, is another ensemble learning method that focuses on misclassified instance during the training process. It assigns the higher weight to the misclassified sample, allowing the subsequent weak learner to focus on previously challenging cases. And the next one is Decision Tree. Decision Tree is a tree-like model that partitions the feature space based on the specific groups and the thresholds. Each internal node represents a decision based on a feature, and each leaf node represents a class label. By integrating the decision tree into the project, the model can efficiently classify the diabetic retinopathy severity by navigating the feature space based on the extracted CNN feature. And the last one is voting classifier. It combines the prediction of multiple individual classifiers, such as of using the previous algorithm, such as of those to make the final decision. It aggregates the output of these classifiers and selects the majority class as a final prediction. By employing a voting classifier, the model benefits from the collective wisdom of the diverse algorithms, potentially achieving the higher accuracy and the robustness in diabetic retinopathy classification. And the next one is of accuracy comparison graph. The performance of each model is evaluated based on their classification accuracy. The accuracy comparison graph visually represents the effectiveness of different models. And the next step is training the model. Once the optimal model is identified, it is trained on the pre-processed data set. During the training process, the model learns from the input images and their corresponding labels, adjusting its parameters to make the accurate prediction. And the next one is user gives the input. A Flask-based web application is developed to allow the users to input the retinal images. Users can upload their images through the web interface for the diabetic retinopathy prediction. And the next step is the given input is pre-processed per prediction. When a user submits an image, the input undergoes the same pre-processing step as of the training image, ensuring the consistency and the compatibility with the model's requirement. And the next one is trained model is used for the prediction. The pre-processed input image is passed to the trained model, which extracts the relevant features through the CNN and apply the selected ML algorithm for the prediction. And the next one is final outcome is displayed. The model prediction result is presented to the user through the web application. The output displays the severity of the diabetic retinopathy associated with the uploaded retinal image. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. the data folder containing of the folders which containing of the various images within it, and the sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the various folders like assets, upload, CSS, JavaScript and Bootstrap files within it, and the template folder containing of the HTML documents like of home, index, notebook, result, sign in and sign up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request and interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the HY files and the pickle files contains the information of the algorithm, and it is loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data, performing the specific operation. A notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in an individual cell, making it a popular choice for the data science. And signup.db is a file appeared to be the database file used to store the user information. And the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folders path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on the enter button. After the app.py file is run, the Flash framework will host the application locally at the default address like this. We need to copy this code folder path and then open the Google Chrome or any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. Here we redirected to this page of containing the title and home and sign up buttons. Click on the sign up button. Here it will redirect it to this page containing of necessary details that are need to be filled to create an account. But my account is already created, that's why I am using the sign in button. Here it will redirect it to the sign in page containing of username and password, and we need to be filled as of admin. And then click on the login button. Here it will redirect it to this page containing of the choose file and upload buttons. Then click on the choose file button. And we need to select any one of the image from it and then click on the open button. And then click on the upload button. Here it will be classified as of the predicted image is of moderate condition. And by using the try again button, here we redirect it to this index file and containing of choose file button, then clicking on the choose file and then selecting any one of the image, and then click on the open button and then click on the upload button. Here it will redirect it to the result page and predicted image app, giving that you don't have a disease. And in this way we can classify predict the diabetes retinopathy by using the various machine learning algorithms with the CNN feature. And this is the comparison graph where x-axis represents the score of each accuracy of algorithm and the y-axis represents the algorithm's names that we used in this project. And this is conclusion of our project successfully demonstrated the potential of machine learning algorithms and the CNN feature extraction and the accurate classification of diabetes retinopathy through the implementation and the evaluation of various models including KNN, random forest, SVM, logistic regression, Neo-Bayes, XGBoost, AdaBoost, decision tree, and the voting classifier. We identified the most effective approach. The results highlight the importance of early detection and the intervention in the diabetic retinopathy, paving the way for improved patient care and the vision preservation. And this project contributes significantly to the field of healthcare and sets the stage of the future advancement in leveraging the machine learning for the medical diagnosis and the treatment.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.